What's up, guys? I don't know if I'm gonna have anyone join me. I was really late with going live. I usually give like 5 minutes to join, so we'll see what happens. Um, I had a good fourth yesterday. Went on like a 10-mile hike and just hung out outside all day for most of it. And let's see. I want to actually, we're gonna do the try, catch, and rescue section of Elixir Getting Started guide today. That'll be a lot of fun. And hey, what's up, Polar Bear? Good to see you, man. I want to just check out Safari. I just added a new feature. Last time I talked about it, and this time I added a little like currently live to the events page. Cool. So now if the time has come, it should show that the event is live from the events page. So that's pretty cool. I just keep having ADHD when I don't want to do my real work. I add silly features to Elixir Mentor. But I think that's cool because now you know if we're live or not, right? I think so. And it looks like our chat is not working today, so that's a bummer. Let's see, no chat box. Unless it's just I guess we'll find out. Dang, that kind of sucks. But I can still read the chats and I'll read them out loud. So, all right, guys, we are going to dive into the Getting Started guide. So let's go to Elixir, not Elixir Mentor, Elixir Lang. I just went blank. And go ahead and click on guides. And on the left side, we're doing try, catch, and rescue. Cool. I think this will be a fun section. Yeah, I'm going to just turn the chat box off. Unfortunately, it looks like nothing's showing up, which is a major bummer. I hate when that doesn't work. All right, so try, catch, and rescue. Elixir has 3 error mechanisms: errors, throws, and exits. In this chapter, we will explore each of them and include remarks about when each should be used. Errors. Errors or exceptions are used when exceptional things happen in the code. A sample error can be retrieved by trying to add a number to an atom. All right, let's go ahead and pull up our terminal. I'm going to just CD to the desktop and then IEX, and I'll make this a little bigger for us. And so, yeah, if we try to take an atom and add an integer to it, we will get an arithmetic error, bad argument, because you can't add an atom and an integer together. And a runtime error can be raised anytime by using the raise arity1 function. So we can go back to our terminal, and if we do raise and then just pass in a message, we get our runtime error with our message oops. Okay, so other errors can be raised with raise arity2, passing the error name and a list of keyword arguments. All right, so this is kind of cool. Let's go back in here. So if we say raise, we can pass in an argument error, and then we can pass in a custom message that we want to be returned. And so we can say in double quotes, it's a string, invalid argument foo. And then we get our custom message back with the argument error raised by a custom message, which is pretty handy. I think we're going to be diving into some more examples to make that more clear why you would pass in custom messages, but it's best for especially logging and debugging, right? So you can also define your own errors by creating a module and using the def exception arity1 construct inside of it. This way, you'll create an error with the same name as the module it's defined in. The most common case is to define a custom exception with a message field. Okay, so let's go ahead and I'm going to clear this so we can read. All right, so I'm going to do something and I don't want to do it, but we're going to just create a module in the IEX shell. So we're doing def module and we're going to call it myAir and then we open up the module with a do. And now inside of our module, we're doing a def exception. And then we can just say we want a message to be part of this, and we can have a default message here. So default message, and then let's go ahead and close out our module. All right, so now if we just do raise and we call our error here, so my error, we'll get our default message. So we get our error type, my error, and then our default message. And then you can also do a raise my error, and then we can pass in our message. We can do a custom message here. So custom message, and when we do that, now we get same our error type and our custom message sent in, which is pretty nifty. Now, errors can be rescued using the try rescue construct as well. So we can do a try, we can do everything in a try block, and if an error is raised, then you can handle the error or handle the logging inside of the rescue. So let's go ahead and pull back up our terminal. So if I do a try do, now anything inside of the try, if an error is raised, which we're just raising one here called oops, then we can do something. We can have our rescue block in here. And in this case, we're just going to say E in a runtime error, because that's what we're going to be getting back. And then we have access to, we're just returning the error here. So whatever the error passed in, we're going to return it. And when we hit enter, I had to end this try block. So now when I hit enter, we get our runtime error struct with the message oops. So the message above rescues the runtime error and returns the exception itself, which is then printed in the IEX session. If you don't have any use for the exception, you don't have to pass a variable to rescue. So we can do the same exact thing without a variable. So we can say try do, and then we can say we can raise our error here, raise oops, and then we can do our rescue, and we can do a runtime error and just send a message back here. So error, and then let's end that, and now we just get our error message instead of our exception that we passed in with a custom message, right? Okay, so in practice, Elixir developers rarely use try rescue construct. For example, many languages would force you to rescue an error when a file cannot be opened successfully. Elixir instead provides a file.readArity1 function, which returns a tuple containing information about whether the file was opened successfully or not. So, all right, if we try to open a file that doesn't exist, I'm going to clear this so we can see. So if I do file.read and we're just trying to read a file that doesn't exist, we get our error back, right? And then if I say file.write and we create our file and we write something inside of it, we create our file, and you can see over my head here, our file is sitting on the desktop. So that's cool. And now if we try to read our file, so if we do file.read again, we get an OK atom back, so our tuple with the contents of the file. And there is no try rescue here in case you want to handle multiple outcomes of opening a file. You can use pattern matching using a case construct. So we can handle, we know that in a successful file read, we get the OK atom back. And when we don't successfully open it, we get an error back. So we can now use case. So we can say in a case block, we can say file.read. And we can say we want to open up our file, hello, and then do. And now inside of our case, we're pattern matching to the OK atom and then assigning the body. So we're binding the body of the file to our variable body here. And then we'll just do an IO puts so we can see it. And we can say success. And then we can share, we can just we can just interpolate our body inside of this string. All right, and then we can also handle an error. So we can we'll get the reason back, right? And then we'll just do an IO puts again. IO puts, and then error. And then we have our tuple, or not our tuple. We're going to interpolate our error in our string here, and that is bound to our variable reason. And then I'll go ahead and close off this case statement and hit end. And we get our success world back because world exists. So that's pretty cool. Let's see. For the cases where you do expect a file to exist and the lack of that file is truly an error, you may use read exclamation point arity1, and then so when this happens, we just force the error to hit, and it won't return a tuple. It will just, so if I do file.read hello with the exclamation point. I don't know why I struggle saying that word. See, we don't get a tuple back anymore. We just get the body. And so if we try to read a file that doesn't exist with this manner, we just get the error back. So file error could not read. So at the end of the day, it's up to your application to decide if an error while opening a file is exceptional or not. That's why Elixir doesn't impose exceptions on the file read arity1 and many other functions. Instead, it leaves it up to the developer to choose the best way to proceed. Many functions in the standard library follow the pattern of having a counterpart that raises an exception instead of returning tuples to match against. The convention is to create a function foo which returns a tuple with an OK atom and the result, or an error with the reason. So tuples and another function foo exclamation point, same name, but the trailing exclamation. There we go. That takes the same arguments as foo, but which raises an exception if there's an error. So foo exclamation should return the result not wrapped in a tuple. If everything goes fine, the file module is good. So I prefer to always have the tuple. I just feel like it's better to handle the error specifically. Like even if you're not returning anything, at least it lets you log the error. And then you also, when it's successful, you just pull your data out of the tuple, which is relatively easy. All right, so where are we? I feel like I didn't finish reading. Many functions I did. Okay. If everything goes fine, the file module is a good example of this convention. Okay, yeah. All right. So fail fast and let it crash. You probably hear that a lot with the Elixir paradigm, right? So one saying that is common in the Erlang community as well as Elixir's is fail fast, let it crash. The idea behind let it crash is that in case something unexpected happens, it's best to let the exception happen without rescuing it. So it is important to emphasize the word unexpected. For example, imagine you are building a script to process files. Your script receives file names as inputs. It is expected that the users may make mistakes and provide unknown file names. In this scenario, while you could use file.read exclamation arity1 to read files, let it crash in case of invalid file names, it probably makes more sense to use file.read arity1 to provide users of your script with a clear, precise feedback of what went wrong, which is usually what you're doing, right? You're going to be wanting to notify someone using your app that something went wrong. Other times you may fully expect certain file to exist, and in case it does not, it means something went terribly wrong. It means something terribly wrong has happened elsewhere. In such cases, file.read exclamation arity1 is all you need. So the second approach also works because, as discussed in the processes chapter, all Elixir code runs inside processes. that are isolated and don't share anything by default. Therefore, an unhandled exception in a process will never crash or corrupt the state of another process. The superpower of Erlang, right? This allows us to define supervisor processes which are meant to observe when a process terminates unexpectedly and start a new one in its place. At the end of the day, fail fast, let it crash is a way of saying when something unexpected happens, it is best to start from scratch within a new process, freshly started by a supervisor, rather than blindly trying to rescue all possible error cases without the full context of when and how they can happen. Re-raise. When we generally avoid using try rescue in Elixir, one situation where we may want to use such construct is for observability / monitoring. Imagine you want to log something that went wrong. You could do a try do with a rescue and then do your logger with the error. See, this is probably the best use case, right? Because then you can check your logs on your server and figure out what is going wrong. You don't necessarily have to you don't have to notify a user necessarily that something went wrong unless it's uploading a file that doesn't exist, right? In the example above, we rescue the exception, logged it, and then re-raised it. We use the stack trace construct both when formatting the exception and when re-raising. This ensures we re-raise the exception as is without changing the value of its origin. All right, so that's pretty cool. Generally speaking, we take errors in Elixir literally. They are reversed for unexpected. They are reserved for unexpected and or exceptional situations, never for controlling the flow of our code. In case you actually need flow control constructs, throws should be used. That's what we are going to see next. All right. So throws. In Elixir, a value can be thrown and later be caught. Throw and catch are reserved for situations where it's not possible to retrieve a value unless by using throw and catch. Those situations are quite uncommon in practice, except when interfacing with libraries that do not provide a proper API. For example, let's imagine the enum module did not provide any API for finding a value that we needed to find the first multiple of 13 on a list of numbers. All right, so let's go ahead and try this example out. Terminal. So I'm going to clear this. We're going to create a try block here, try do, and then we're going to say enum.each. So we're just iterating through -50. We're doing a range here, so -50 to 50. And then inside of this, every value, we're going to see if it's divisible by 13. So we're looking for the remainder of x. If it's divisible by 13, that means it equals 0. Then we're going to say do, and we're going to throw an error and pass in the value. And then we're ending this and closing off the function parentheses. And then if the if statement is never hit, we're just returning got nothing. And then in our catch, so when we throw the error, we're catching that value x, right? And then we're just going to say x, and we're going to just return a string that says got, and then we're going to say what value we got, and then we'll end. So now when I hit enter, it should find a value divisible by 13. And there we go. The first value divisible was -39. And so catch is not caught unless you do a throw in the try block that you're trying to do. So let's see here. I kind of want to reread this. A value can be thrown and later be caught. So yeah, we threw an error and then we handle it in our catch here. So since enum does provide a proper API in practice, we can use enum.find arity2 is the way to go. So we can just use this function instead, and it would return the same thing for us. And they would handle the errors, right? So all Elixir code Oh, exits. All Elixir code runs inside of processes that communicate with each other. When a process dies of natural causes, e.g. unhandled exceptions, it sends an exit signal. A process can also die by explicitly sending an exit signal. So we can spawn a process here with spawn link. And so if we say spawn underscore link, and then we're just going to, learn how to type. And we're just going to call exit, and we're passing in a message just 1 and then end. And when we hit enter, we get our exit, and it tells us that the process was exited with reason 1. So in the example above, the linked process died by sending an exit signal with a value of 1. The Elixir shell automatically handles those messages and prints them to the terminal. Exit can also be caught using try catch. All right, so back to the terminal. So we can do try do, and then we can just call our exit here and send in a message, I am exiting. And then we can do our catch here. And if it's an exit, so if the error is an exit, so we're pattern matching here, and we don't care about the value, just the key. We can return a message, not really, then hit end. And since exit was called, this pattern was matched, and we returned not really. All right, catch can also be used within a function body without matching try. Without a matching try. So you don't necessarily have to have the try block. We can just throw a catch, and then if an exit signal is hit, we'll take care of it in a catch. So let's go ahead and try that out. I'm going to just clear this so you guys can see it better. I feel like we should open code, our code editor. Let's do it. Let's control C, and we'll just, let's see, touch, and we're going to just call this example.ex. And then I'm just going to open Visual Studio Code, close that, and then open a file on our desktop called example.ex. Okay, so if we have a def module here called example, def module, when autocomplete messes me up, delete that. All right, so we have our module here called example, and then we're going to just create a function called def matched catch, and then do, and we're going to just exit with an atom timeout, and it helps to have a colon. There we go. And then inside of this function, we can just have our catch block right underneath this. So catch, and then we can pattern match our exit and the message of timeout, and then return, and then handle this exit however we want. And in this case, we're going to just return a tuple with an error and a timeout atom. All right, so if I save this, cool, and then let's see, and now let's, I believe, how can we do this? ix-s mix. How do I compile just a file? I'm blanking on this, guys. Is it just Elixir? And then, yeah. And then I think I can do example dot, what is our function? No, this isn't going to work. Maybe I just open up the IEX shell here. And then can I do example dot matched catch? I'm blanking so hard right now. It's Friday. And I do this all the time. I need to Google. Compile file with IEX shell. Use the C file. How to compile a single file in Elixir. Oh, I have to, okay. So if I do IEX, I'm already in there. If I just do C and then the name of the file, right? Cool. Okay. All right. And then example dot match catch. All right. Thanks for hanging in there with me, guys. Now I have to find where I left off. Okay. So catch can be used within a body function without a matching try. And so we just saw that and we got our error timeout. Now, let's see, however, using try catch is already uncommon. Okay. But then if we have a mismatched and we send in a timeout Atom message and we don't match for it, it is going to have, so let's see, since no clause matches, this catch will have no effect. So we'll probably get a default error message. So let's try that out. All right, so if we do def mismatched catch do, and then we're going to do an exit for timeout, and then our catch, and then we're going to look for exit explosion. And we're going to just return a tuple here with an error type and then explosion and then hit save. And so we're sending in, we're exiting our process, right? Or sending a exit signal with a message timeout, but it's not going to pattern match to this, to explosion. So let's save it and see what happens when we call the mismatched. So let's compile our file. And then if we do example dot mismatched catch, we get a timeout. Let's see. Yeah, we just get an exit timeout, mismatched catch. So it didn't call our custom, so we didn't get our custom tuple back. We just got the default error message, which that makes sense, right? But if we were to send in explosion here and recompile and call the same thing, now we get our tuple back. So we don't get our exit timeout error. We actually handle the return, so we don't just get our unhandled error, which is cool. All right, let's see. However, using try catch is already uncommon, and using it to catch exits is rather rare, or is even rarer. Exit signals are an important part of the fault tolerance system provided by the Erlang VM. Processes usually run under supervision trees, which are themselves processes that listen to exit signals from the supervised processes. Once an exit signal is received, the supervision strategy kicks in and the supervised process is restarted, which is pretty awesome. I think, do we get into processes in this guide? Not in the getting started, but maybe we'll just keep going and touch on that. I do touch on processes in my Elixir A Comprehensive Introduction course, and that's pretty dope. And currently, until Monday at midnight Mountain Standard Time, you can get 45% off if you use Sparks 45, and you can find my course on my website. And that's an awesome way to support me if you guys want to. And let's see. Where was I? Exit signals are important part, blah, blah, blah. Yes. Okay. Once an exit signal is received, yeah, it restarts. It is exactly this supervision system that makes constructs like try catch and try rescue so uncommon in Elixir. Instead of rescuing an error, we'd rather fail fast, since the supervision tree will guarantee our application will go back to a known initial state after the error, which is pretty awesome, right? Like if a process fails, it just will restart. All right, after. Sometimes it's necessary to ensure that a resource is cleaned up after some action that could potentially raise an error. The try after construct allows you to do that. For example, we can open a file and then use the after clause to close it, even if something goes wrong. All right, so back to the shell. I'm going to just clear this so we can see. Okay. So we're going to bind, we're looking for an OK atom returned file is what we're going to bind it to. And we're going to say file.open, and we're going to open a file called sample. And we want it to be of UTF-8, and we want it to be writable. Okay. Close that. And now we're going to, all right, so we have a process there, and then try do io.write file, and then we're going to say, I'm not going to type in these accents, but we're going to, I need a comma, not a period. Close parentheses, and then we're going to raise an error. Oops, something went wrong. And then we're going to have our after block, our after catch here, whatever our, what is it called? Our little cleanup action. And then we want to say file. We want to close the file. So we want to close this process and then hit end. And then when I hit enter, we get, oops, something went wrong. And that is, it does exist. Oops, something went wrong. And let's see, the after clause will be executed regardless of whether or not the try block succeeded. Note, however, that if the linked process exits, this process will exit and the after clause will not get run. Thus, after provides only a soft guarantee. Luckily, files in Elixir are also linked to the current processes, and therefore they will always get closed if the current process crashes. Independent of the after clause, you will find the same to be true for other resources like the ets tables, sockets, ports, and more. Sometimes you may want to wrap the entire body of a function in a try construct, often to guarantee some code will be executed afterwards. In such cases, Elixir allows you to omit the try line. All right. Let's pull up the shell. So we can do the same thing. We can call it, we can do def module run after do. And then inside of this, we're creating a function called without even trying. And we're going to raise an error here of oops. And then we're going to have our after action and then IO puts. And we're just going to put a message here called cleaning up so we can see if it actually runs. And then end. Whoops, what did I do? I hate working in the shell, guys. All right. I missed a parentheses. So we have our def module run after. We're creating our function without even trying. We're raising our oops error, and then we're running our cleaning up, or we need our after, and then our cleaning up, which I forgot the closing parentheses. And then we have to end that, the raise block here, and then end our module. And then we're going to call this function with the run after module, and then just call the without even trying. And we're raising our error, and then we're going to see that even after our error raises, it's still going to run the after block and do the cleaning up code. Yeah, so we see our IO puts there, and so the after block runs even after an error was raised, which is pretty cool. Elixir will automatically wrap the function body in a try whenever one of the after, rescue, or catch is specified. So like we didn't need to have the try here, and you can always use the after, rescue, or catch functions in the body there. And then we have else. If an else block is present, it will match on the results of the try block whenever the try block finishes without a throw or an error. So, okay, we'll do this example in the shell. Make sure there's no, hey, what's up, Q? Glad you're here, man. All right, so, oops. Okay, let's try out this else example. All right, I'm going to clear this. All right, so we're binding a variable x to 2. And then inside of a try block, we're going to say 1 divided by x. And then we're going to do a rescue. And we're going to throw a rhythmic. I forgot an H. So a rhythmic error of infinity. Else. So like obviously we would throw the arithmetic error if like 1 divided by 0 here, but then in the else statement we're going to do y when y, we're using a guard here, is less than 1 and y is greater than -1, then we're going to return the atom small. And then for everything else, we don't care what we're matching to. We're just going to return the atom large. And then we can end this. So right here, we're going to do 1 divided by x. Okay. And so 1 divided by 2 is going to be 0.5. So we're not going to hit the rescue here. So that means then else will automatically get initiated and this value will be passed in, and we should get small back because it's less than 1 and greater than -1. So hit enter and we get our small atom back. So exceptions in the else block are not caught. If no pattern inside the else block matches, an exception will be raised. This exception is not caught by the current try block. So else is outside of this try block. Okay, so that makes sense, I think. So variables scope. Similar to case, condition, if, and other constructs in Elixir, variables defined inside try, catch, rescue, and after blocks do not leak to outer context. In other words, this code is invalid. So let's see, we have our try block, we raise, fail, and then we have our rescue, undefined variable, what happened. So you're not, we raised fail, and we don't have access to the variable what happened outside of the try block, which makes sense, right? Instead, you should return the value of the try expression. So the try expression is now bound to what happened, and then we have access to whatever returned there. Let's go ahead and actually we'll do this example. Since I'm in the shell, I'm just going to bind it right away because I don't like, we know it's going to be out of scope when we're just trying to call the variable inside the block, right? So I'm going to just say what happened equals, and then we're going to do our try do, and then we're going to say raise, message fail, and we can say, then we return did not raise, and then we can do a rescue, and we don't care what the value is, and we're just going to say atom rescued is going to be returned. So rescued, there we go, and then end. And when I hit enter, we get the value back of rescued, but we also have access to what happened now, and that's rescued. So we're just binding whatever happened here to the variable what happened. So you can't call any, you don't have access to any variables inside of that block because it's out of scope. So furthermore, variables defined in the do block of try are not available inside rescue after else either. This is because the try block may fail at any moment, and therefore the variables may have never been bound in the first place. So this also isn't valid. Try block, we have our raise fail, another what happened did not raise, and then rescue, you can't call a variable from the try block in the rescue, which that makes sense. So undefined variable. So this finishes our introduction on try, catch, and rescue. You will find they are used less frequently in Elixir than in other languages. And next we will talk about a very important subject to Elixir developers, writing documentation. So that'll be fun. And I can't remember when I'm doing that one. My schedule, I'm out of town for a part of next week, but let me just go to my events here. So July 11th, and I believe July 11th is next Thursday. So next Thursday, we will be doing the writing documentation section. So that'll be a lot of fun. And thank you guys for everyone that joined me. This was a lot of fun learning all about our try, catch, and rescue. And I will see you guys on Thursday. Enjoy your weekend.
Enjoying the video? Show some love with a like and hit subscribe to stay updated. To support me and keep the content free, click join for memberships or pick up a course at elixirmentor.com and get free access to my private community. Let's jump back in.
And also, until Monday at midnight, if you use the code SPARKS45, you get 45% off my Elixir comprehensive introduction course. There is currently 10 hours of content in there, and I am still making more. So it's a good time to jump on it until I completely finish it. So, all right, guys, have a good weekend. Thanks for joining me.